Next up, we've got the second workshop slated for today. I'm inviting Ulysse to the stage, who will be telling me something about integrating ckBTC in DApps with Taler. So Ulysse, feel free to, he's here.
Yeah, you can hear me?
Yes, we can hear, we can see you, share a screen, and the floor is yours.
Yes. I need to share my screen. And that's it. So hi everyone, welcome to this workshop around ckBTC, and thanks Neven for the invite. I'm Ulysse, and I'm part of a team contributing to 4 different projects on the internet computer, such as the Taler DAO, which is a decentralized stablecoin, and Water Neuron, liquid staking protocol on the internet computer. In a few days, on Friday the 14th, we're going to launch the SNS for Water Neuron. So please feel free to check out the Twitter at Water Neuron to see the last update about the project. And I think there are going to be a lot of different cool features for you. So yeah, definitely check the Twitter account to keep to be updated. Although our team at Sisyphe our goal is to kickstart DeFi on the internet computer, because the internet computer has such potential, has so much potential in terms of scalability, Web2 integration, and chain fusion, of course, in a decentralized fashion. So it's really interesting here. On our team, we have 2 in our ranks. We have 2 ex-Dfinity members. If you don't know what Dfinity is about, it's a foundation that has helped create and build the internet computer since the start. And one of our engineers has built ckBTC and the chain key technology that I will be explaining to you a little bit later. But that's enough about us, right? Let's talk a little bit more about you. Because if you're here, I think it is most likely that you are a developer, right? And that you love crypto. So what I want for you is to start coding actually a canister and a smart contract to get a good grasp of how you can integrate also the Bitcoin blockchain into the internet computer. And so what I have planned for you basically is a little explanation about the design of this chain key technology, and then we are going to see how you can create your own canister and leverage this technology to integrate Bitcoin into your decentralized application. So let's dive into the presentation first. Here, so of course I will assume that you have some basic knowledge on the internet computer, right? But if you don't, or if you have any questions along the way, please feel free to ask them right away, and I will try to answer them. So on the internet computer, you have different subnets, and each subnet is composed of ICP nodes. ICP nodes is basically computers that are talking to each other to verify transactions in the blockchain and also to execute a smart contract code. But what is really interesting on the internet computer is that each of those computers also run a Bitcoin node, which means that Bitcoin is directly integrated on the internet computer in a decentralized fashion. This design has a lot of different applications, but tonight we are going to talk about a basic application, but that might be the most useful one for you when you code your application and your smart contract. And this is called ckBTC. So what is ckBTC? Let's say first that you are a user on the Bitcoin blockchain and you want to send your Bitcoin on an internet computer application. What you're going to do actually is from an ICP address, you can derive a Bitcoin address that we call UTXO for unspent transaction output. And you will send your Bitcoin to this UTXO. Then you can interact with the minter, ckBTC minter. It's a canister that has been developed by Definity. And you can interact with it and tell it that you have just sent some Bitcoin on your address, and then he will check the amount of Bitcoin you have and update your balance of ckBTC on your ICP address. And if we look a little bit further on how the minter works, actually, it's a bunch of Bitcoin addresses, UTXOs, and he keeps track of them. Once someone deposited Bitcoin and called it to update the ckBTC balance on the ICP address, it keeps tracks of those Bitcoin addresses. And once someone wants to send their ckBTC on a Bitcoin address, then he's going to take one of those UTXOs and transfer the correct amount of Bitcoin on this address. That's how you exit your Bitcoin out of the internet computer blockchain. But let's look a little bit further also on what you can do with those ckBTC locked in the ICP address. You can, of course, use Taler DAO, one of our projects, which is a decentralized stablecoin. Here we are going to talk a little bit about the design of this stablecoin, which is a collateral debt position. Why? Because afterwards, when we are going to code our smart contract, we will leverage this design that directly integrates ckBTC. So how does it work? You're a user and you can send your ckBTC on what we call a vault. This is your collateral and it has a certain amount, right? And from the collateral, you can contract a certain amount of debt in BTAL. BTAL is pegged to the dollar. Here, I'm not going to talk about around the specifics and how the BTAL is pegged to the dollar. But what is important to understand is that each BTAL is backed by a ckBTC, and the collateral amount you have in your vault is higher than the amount of debt you contracted in your vault. That's how you keep the protocol healthy, of course. Like that, you ensure that each BTAL is a store of value, right? One way to measure the health of your vault is to compute the collateral ratio. It's a basic division of the collateral over the debt, but thanks to that, you can know if you have sufficient collateral in your vault. Why? Because there is what we call a liquidation threshold. And here in the graph, if you're below that liquidation threshold, which means you have more collateral than debt, then you're okay, your position is fine, and you're happy, basically. However, your collateral ratio might go above the liquidation threshold which means some of your debt, some of your BTAL potentially is not backed by any ckBTC, so it's worth, it's not so value, right? So then you are not happy. Why? Because they are what we call liquidators that can say, hey, your vault is mine now, I'm going to repay your debt, but then I will retrieve the collateral, and basically you will lose everything. That's how, this is how the design works, and basically your position gets liquidated. In a moment, we're going to code our first smart contracts and actually build a canister that is recording different vaults and tries to compute this collateral ratio. But first, let's one last thing first. We are going to look about how to exit the ckBTC out of the internal computer. You have a transaction that is represented by this envelope, and from this transaction, a smart contract is going to pass this transaction through the ICP subnet in order to sign this transaction with what we call a threshold ECDSA signature. And this signature is compatible with the Bitcoin network, and then only you can send your transaction to the Bitcoin nodes and add it to the next block on the Bitcoin blockchain. So that's basically how the chain key technology and ckBTC works. And then we're going to dive into some interesting thing, which is basically code our first a smart contract, right? So here in this repository, I have written all the different steps you have to deploy a smart contract that interact with some other canisters that have been developed by Dfinity, because you might already know it if you have coded a different application, but because Dfinity has implemented so much tools in order to use correctly the internet computer, it is most likely that you will use their canisters. So here is a direct integration of some of their canisters into our code. And let's see how this works. Of course, you can clone the repo at home and try to reproduce the canister, right? I've done it myself. Here is the cloned repository with all the files, and we are going to be looking at it a little bit later. But first, let's let's set up our canister. Let's say you're a developer, you want to build an app. How you can start? Maybe some of you already know that, of course, but I think it's good for those of you who do not know, to see how it works. So we are going to use the Rust language as a backend language and add a front-end framework, which will be a React framework. And let's create our first canister. We are going to look at the repository we will have once everything has been set up. Of course, the DFX tool is doing everything for us. So now I can open it, and here it goes. So I have my repository, my canister, and let's look at what we can do with it, right? So I'm not going to go in details with all the different files, but what you have to look for is, of course, the Rust code that represents the basic mechanisms. This is where you will implement everything, basically. let's look also at the DIT file and the dfx.json file. For now, we're gonna left the front end, and maybe if we have time in the end, we can look at it. But for now, let's focus at the backend canister, right? So what you're going to do is start to deploy a local replica of the internet computer. And this you can do so by running dfx start clean, and we're gonna do it on the background. Once you have done that, you can wait a little bit. Now it's okay. And we are going to deploy our mock canisters. So for now, of course, it's the basic setup that has been implemented by Definity. So there is not much, but it's useful to understand where to look at when you code a canister, etc. So this is pretty cool. And in the end, you will have two HTTPS addresses that we are going to click on to look into what is going on with our canisters, right? But first, let's look at the different files. So we have our code here on the lib.rs. Okay, simply it's printing the hello and your name. And you have a DIT file. And the DIT file is quite interesting. Why? Because actually you will have to specify the different functions that your canister will be using along the way. And here we can see, so we have the greet function, and we specify also the types of the inputs, the types of the outputs, which is text here. And we can specify if it's a query or not. I'm going to explain what's the difference between a query and an update a bit later on. But here we have our canisters, right? So let's look at what it's looking like. So we have a canister and we can enter our name. It's greeting me, all right. So this is fine. And usually you go to this interface, this UI, Candid UI, to look at your canisters and test a little bit the samples. Test with some different examples, sorry. But basically, we're far from having vaults, etc. What we are going to do now, and you can check actually the repository I made, because we are here on the first step. But the second step, once you've deployed, is to change the different files with the files I have on the clone repo. So let's take this file, take this content, basically copy paste, because we don't have the time to write everything. So it will be much easier to do it that way. We're going to, of course, specify everything. So that's fine. And finally, the toml file. This is the three main file to use and to modify in order to implement our logic. And let's look at them one by one. So actually, our application is basically a set of different vaults. That's what I want. So of course, I'm going to create a type, a struct that represents the vault with some ckBTC and some vital. And I can compute the collateral ratio. But for that, I have to specify the price, because self vital is pegged to the dollar, so it's only multiplied by 1. But then we check the Bitcoin price and we do the ratio, and we have our collateral ratio basically. This then we are going to create our state, so the list of the different vaults that will be in our application, right? Why are we using thread local macro? It's a good opportunity for me to share to you this blog made by a former Definity engineer, Roman Kashitsin. And basically, it's super interesting, and he speaks about that and why we are using this macro. Why is it good to use this to declare a state? Of course, you're not supposed to know Rust. Maybe you can, because you can code canisters on Python, on Motoko, different languages. But if you do code in Rust, then definitely check out the blog. That is quite interesting, right? Then what we can see after that is a bunch of different functions that are actually the ones that we'll be using, that we will be using on our canister. I specified some macros. The init macros only tells that this particular function, will be used once at the time of creation of the canister, and then it will not be called again. And then you can specify either an update function or a query function, and that is represented also in the did file. Here we have two, on those two lines, two updates, and on the last one, a query. What is going on is when you do a query, it's often because you want to get some reference of the state, something in the state. You only want to check a particular value, but you don't want to change the state. Then you use a query, right? And what is happening backstage is actually the canister is going to call the boundary nodes, but there are no consensus required to get the answer right away, so it's fast. On the other hand, you have updates where you modify the state of the canister, and then the code has to be there has to be a consensus with the different nodes, so it takes more time to actually do that. That's the main difference between an update and a query, right? If you look at it, basically the first update is only to open a vault with some amount of ckBTC and some amount of BTAL. You can also retrieve the state of the application and the list of the different vaults there are, and finally get the collateral ratio. Of course, I'm not going into specifics about how to code those functions, and because it's specific to the Rust language. So if you don't know Rust, there is no point, but you don't need really to make it happen and to code to deploy this canister, right? Also, one thing to look out is the fetch Bitcoin price, because as I said earlier, on the collateral ratio, when we compute it, we have to specify the price, so we have to fetch it. And it's a good time for me to introduce another cool feature of the internet computer, which is HTTP outcalls, which allows fast, you can retrieve data from Web 2 in a much faster way than you can on other chain. But for that, in order to fetch the Bitcoin price, we'll have to interact with the exchange rate canister. It's a canister that has been developed by Definity, and it allows to fetch different rates on the blockchain. So what you want to do is to specify the principal, because each canister has a principal, and you want to specify it before calling the canister, specify the ID also of the canister in order for the app to correctly deploy and execute the code. But here, as you can see, you don't have that. So you have to download it. You can either check the repository, and here I put the link of the exchange rate canister, and you will reach for the WASM and the DIT file. WASM actually is code, and it can be Rust code that is compiled into bytes, WASM bytes, and it's a compressed version of the code. So you can just copy it right away and integrate it on our canister. So a simple copy paste, right? Now we have our exchange rate canister, but actually what you want to do is to go to the dfx.json file and specify that you added the XRC canister. So you can simply go to this dfx.json file, copy paste again. Actually, you're only adding this line of code, which is the path of the WASM file and the JIT file. That way, you have declared all the canisters that will be used in your application. And if we look at the next step, because here we just downloaded that, so we're good to go. We modified the JSON file. The goal here is for you really to reproduce it at home. I think you'll manage to do that. But of course, if you have any questions, you can ask me on Twitter, and I will answer you if you're a bit struggling with how you can deploy your smart contract. What we want now, of course, is check if our code is correct. So let me grab that and stop, of course, the background. I'm going to work on two terminals. Like that, I can have the dashboard here, and I can try to deploy the XRC canister first. We're going to create it, and once we've done that, we're going to try to, okay, that's perfectly done, so it's fully integrated into our application. Then we're going to try to deploy the Vault backend and see what happens. Okay, first error, of course. Yeah, of course you have to build your code before trying to deploy it. So you just have to specify the target. Here it is WASM32, a noun, but again it is specific to the Rust language. So if you're coding on Python, it might be different. But here you can build, compile all your code, and once that is done, we are going to deploy it again. As simple as that. Oh, of course, I forgot to suppress the previous file. So now we can proceed in upgrading the canister, because before it was a greeting, now it is not. And we have our Vault backend. So we're happy, right? We should, at least. We're going to look at the Vault. So there is no Vault. Maybe we want to add one. So with 10 ckBTC, 1000 Vital, here it is added. Okay, it is in our application. We're happy. So now let's retrieve the collateral ratio. In input argument, it's the index of, because we have a list of vaults, so it's only the index where that tells where the vault is located. And look at what happens if you do that. Okay, the code is rejected. and we can look why. So if we first, one thing to check is the ID of the XRC canister, and we can see that it does not match this canister. That's why it's not working, but no worries. What you can do is start again and start it clean like that. You have to do it all over again, but it should work well, as you will see in a few moments. So let's look at the ID, the canister ID. Oh, and we don't have a lot of time, so maybe I'm gonna speed up. Okay, let's just yeah, here the ID, it does match this place. So what you can do is here, sorry, to deploy the void backend canister, void backend. I'm almost finished, of course, and afterwards we're going to check this. So now we have a vault. We're going to check the collateral ratio. What we can see is that it should not work right. It should not work correctly. And if it does, and it does, it's simply that something I wanted to show you is that you have to specify a cycle cost, because in order to execute the code, the XRC canister needs cycle, and you can deposit cycle in this canister by running the command dfx canister deposit cycles, and the amount of cycles you want, let's say this, and you have to specify the name, then it's deposited, and that's what is working for you. And then you can also check the status of the canisters, which is the XRC, to look at the balance of cycles you have. And here we can see we have plenty of cycles to run the canister, so we're happy, right? One last thing to say is when you started the replica, you might have a different message here about the network.json file, and I have specified it in the README. You might have encounters does not define it, or the network.json not found. Both of those message errors can be resolved by running this command first to create the file. Then you can use nano and insert this in the file in order for it to work properly and locally. So I think it's time. I'm good, because I don't think we have a lot of time left. And basically that's how you can develop a canister. Of course, here there are still a lot of work to do in order to integrate ckBTC in your application. And I mentioned it also in the repository, but for that you have to interact with the ckBTC ledger and the ckBTC minter as well. I put all the sources in order to understand how to integrate it, and here we can click on it, and you have all the steps to integrate the different canisters. And of course you're not there yet. The app is not ready still, but that's at least a a preview about what you can do with while coding canisters on the internet computer. So that's what I wanted to show you, and yeah.
Cool. I think we're over time at this point, so I don't think we have any time for any questions, except maybe Ulysse could do maybe paste the link to the GitHub repo you just showed in the chat so people can. And by the way, everybody else, tomorrow morning when we share the recording of the session, you can go through all of it again, and of course we will share the link with you there as well. Like Matthias says in the chat, this very much had the feeling and the joy of live coding. There's always the unpredictable nature of running or not running your code and not being able to do everything exactly how I wanted, but that's why we're here. We love it. Any final words, Ulysse?
Yeah, because of our recent activity, definitely check out Water Neuron, because this is a pretty cool project, and I think you can benefit from it. So yeah, definitely check this account on Twitter, and thank you for watching this workshop, for attending this workshop.
Cool. Amazing. Thank you very much. And thank you to all of you for coming. See ya on Thursday at the same time for the next event. Until then, stay cool and have a lovely evening or the rest of your day.
Thank you, Neven. Bye.